Okay, so we've talked about straight streams, which tend to be in places where we're far from base level. We're talking about meandering streams, which tends to be in zones of transportation. Where we talked about braided streams that tend to be in areas of deposition, or often can be in places where you at the lowlands, or in places where you have a change of velocity. Okay, so they can be in multiple places, but often because of the change of velocity or change of sediment load. Now, I'm going to stop here for a second and remind you that I'm not expecting you to get through all these videos this first week. This is going to be over a 2-week period. I'm just doing all the lecture slides, all the lecture videos all at once for the both weeks. Okay, just a reminder for you. Okay, so this is kind of a review to see what you see here. Now here, hopefully you'll see how far away is this river from its base level. Now what you'll notice here is you have this nice meandering river going across here. So if you have a nice meandering river, that means you're going to be close to its base level or far away from it. And hopefully you said that it's going to be closer to its base level. So this would be in an area where we call the zone of transportation, where we have this big floodplain where you can see on this side where the streams used to be. You have these little scars out here where the stream used to be, right? Okay, you can even see it in some of where the trees used to be. The trees like to actually fall places where you have lots of coarse sediment, and so that's where you have old scars. You can even see some of these old oxbow lakes out here where the channel used to be, right? So this is the big floodplain here. For those who don't know, that white stuff's snow. This is near my hometown, where you have these big lava flows, and the river is cutting through, forming these cut banks on one side, and the point bars on the inside corners, right? Okay, as it goes downstream. And what it's grading itself to is there's a lake down here that's actually grading itself to. And so, so the ocean is the ultimate base level, but it also is going to grade itself to that lake. A lake is what we consider a temporary base level, because over time it's going to slowly go away. When I say time, we're talking about geological time, thousands of years, hundreds of thousands of years. Okay, but the ultimate base level is the ocean. Okay, so this is the Snake River meandering across the floodplain, and you can see all the different meander scars and things from there. Well, what about this one? Is this stream right here, okay, close to its base level or far from it? Well, this one, you can see the meanders to it, and so it's actually have its energy going side to side, okay? So this is close to its base level. And if you look out here, you kind of can see it as starting to form a lake here, out here. So it's grading itself to this lake. But what about this stream up here? There's a nice little V shape here. This one has kind of a U-shaped valley to it, okay, at the bottom here. But up here is a V shape. So this stream, which is a smaller stream, that's actually slowly going into over here, and it actually, notice it has these distributaries because you found an alluvial fan right here. There's another alluvial fan right there, and that you can see as a fan structure as it comes out of these V-shaped valleys. Okay, there's other ones down here as well. But the point comes is this stream is far from its base level, and this one is close. Well, why do you have two streams right next to each other? One's far from its base level, one's close. Well, this one has more discharge. It has more water in it. Because it has more water, it has more power to it over time, and it's slowly eroding away. Whereas this one doesn't have very much water. It's even what we call an ephemeral stream. It doesn't flow all year round. And so therefore, it only flows and only erodes during floods and during storms, and slowly eroding away and forming this alluvial fan where it goes high velocity, low velocity, depositing the sediment. Right? You guys get it? Okay. So you have these nice alluvial fans, the floodplains, the V-shaped valleys, and a stream near its base level. Okay. What about this one? What's this fixed feature? Notice it's not connected to the river that's over here. Well, this is actually an oxbow lake. This is actually in Minnesota. I think this is in St. Paul area, if I remember right. You can see the stream actually goes out and then comes around, goes out over here, back around, and over and down. And this is so the meander stream, not quite where it got it, but it's pretty close. Whereas this is an old oxbow, which means it got cut off as it actually was flooded to that area, depositing its sediments to cut off the meander. Okay, so we keep going here. It's an oxbow lake. These are aerial photos, and these are actually false coloring images. To actually, you can see the scars a little bit better. You can see these old scars of the floodplain as the stream goes all over the floodplain. Okay, and this is old oxbows that you see in the region where the stream is way over here. Okay. Okay, so all those are point. You can see the point bars here too. The white areas here where it's depositing. The cut banks are on the outside where it's actually eroding away. Okay. So here's this one. You can see the braided stream, which means that there's too much sediment in the water, and therefore it's actually forming these distributaries, right? And if you'll notice, as you go down, and you're starting to lose those distributaries because all of it, it's actually all that sediment's forming out. So now it's starting to slowly get back to a normal stream. So this would be a good example of a braided stream. Usually happens in areas where you have lots of sediment, where the river can't carry it anymore, or places where you have a change of energy, like at the mouth of a canyon, or at a delta where it's going into a river or a water body, like the ocean. Okay. Okay, so which of these channels, if you looked at this picture, these three pictures, which of these would be furthest from its base level? Which channel is far from its outlet? Well, we could tell by just looking at these pictures. Okay, this is meandering back and forth, so we know that this one is close to its base level. Okay, because it's going back and forth. This one has a lot of braids in it. Okay, which means that it's going from high elevation to low elevation suddenly, and also dropping its sediment. Okay, and it looks like the sediment's kind of clay rich, anyways. This one here has really coarse sediment, so it's probably up in its headlands. Okay, a lot of it has rapids in it, so this one's far from its base level, and it's probably going to be even in a V-shaped valley. So this one here, C, would be in its headlands. Okay, far from its base level. Whereas this one would be close to its base level, and this one might be even at its base level, or almost going into a river body or to a ocean or a lake or something. Okay, so which channel is most likely in the zone of erosion? This one again. Okay, this one. Which channel is far from its outlet? C. Which one is likely in its zone of erosion? C again. Okay. Which one is likely in the zone of transportation? B. Which one is likely in the zone of deposition? A. You get it? Okay. Okay. So that is where we'll stop. Where we stop for the section for the first week. The rest of this material is stuff that I would suggest will be covered in the next week. Now, you can watch it all this week. That's fine. But from here on is about where I stop talking about stuff for the next week. So the assignments and stuff like that will be coming from there prior for the first week, and from here on for the next week. But since it's all the same kind of topic, we're to continue on with these lecture slides. Okay? So we've talked about floods a little bit, but what is a flood? Well, a flood really is any time the water goes above its banks. So what we have here is a river here where the water is in its channel. So it's below its flood stage. The stage is the height, okay, of the water. Now, if it was right at its top of its banks, we'd call that its flood stage. That's where it will start to flood. Anything over that, it's going to be in flood. Okay, it's going to be flooding. The river's going to be flooding. And if it's just at that flood stage, that means it's just right at the top there where it's not flooding yet, but if you go over any bit more, it's going to start to flood. Okay? So a flood is any excess water that is above its banks. And so some floods can be very big and some floods very small. If the water is just barely a couple inches over that banks, it's only going to flood maybe a little bit portion of water right next to the edge of the bank, right? Whereas if, let's say, it goes well over its banks, it's going to go outwards from there and maybe go hundreds of feet or maybe even miles to side if the floodplain is really big. So, for example, this is the hydrograph for the Mississippi River near St. Louis, Missouri. And this is its flood stage. Here, this flood stage was at 30 feet above the bottom of the river. Okay? So this is the elevation of it before. It actually relates to how much discharge goes down to it, right? How much water is going down or volume is going down per area. And so as the flood stage goes, anything below this, all the water is contained in the river. Okay? But as soon as it gets to that height, it's no longer contained in the river. So now it's flooding the local area. This flood back in 1993 was one of the biggest floods in U.S. history. And this flood actually went over 20 feet over its banks. Okay, so if it goes 20 feet up, it's going over long distances horizontally. So it's going miles and miles out there and flooding large swaths of areas, houses, farms through these areas. Now notice something here. This is actually the date in which it happened. Okay, so it started to flood about May 26th to 27th, went to the flood stage. And it was flooding in this area until it went back down for a little bit, but then went right back up all the way till October. So some of these areas were flooded for almost, what, 1, 2, 3, almost 4 months, okay, completely underwater. This was a big, big flood, and it was caused mostly because the area was very saturated with a very wet spring, and then the snow melt happened really quickly, and so all of this water flooded down into the lowlands, causing the flood to go out in large areas, a huge flood area. It was one of the most destructive floods for a long time. It's what we call a regional flood. A regional flood is a flood that actually is caused over rainfall over multiple days. It's long lasting, sometimes weeks, sometimes even months, and it builds up slowly and dissipates slowly. Right? That's a regional flood. Very much like the flood that occurred during Hurricane Matthew. That was a regional flood. It came down and actually flooded that area and stayed high for quite a while. However, during Hurricane Matthew, we also had local thunderstorms, and those local thunderstorms caused flash floods. And those are the ones that actually come very quickly, only last a couple hours, and then go down, and then the water level goes down afterwards. These ones are usually fairly quick. They don't actually last very long, and they usually happen in the headlands. So flash floods usually occur in the headlands, whereas the regional floods usually happen downstream in the lowlands. Okay. Now there are other types of floods that you can have too. You can have storm surges because of hurricanes, which we happened during Hurricane Matthew and Florence and some of these other hurricanes. We had some big flooding caused by storm surges. Or you can have dam breaks, like ice jam floods, where you have ice on a big lake actually accumulating at the mouth of the river, so therefore it backs up and forms a dam for a little while, and then it breaks and goes down. You can have natural dams like landslides going into a river that therefore dam the river for a while, and then it fails going down. You can have human-built dams or levees. For example, my hometown actually was destroyed when I was born. The whole town, our house, was actually picked up off its foundation and flowed downstream, down Main Street actually. And was completely destroyed when I was just a small child. And it was caused because a dam upstream failed. And that failed dam came down and completely flooded the region. Okay? So these floods can have huge erosive power behind them. So when you have floods is when you have the vast majority of the erosive power. Here's an example of that regional flood. This is the one I talked to you about in 1993 for the Mississippi River. So here is St. Louis and notice that this is the Mississippi River here and the Missouri River coming in, connecting together. And this is where you had all of a sudden got backed up. So here's the Missouri River, the Mississippi River coming together, backing up, forming these really wide areas here. So just as a side note, this is an aerial photo looking from well high up, satellite photo. And this distance back here is almost about 3/4 of a mile. It's a big river. And now you have it going all the way across here. It's almost about 10 miles across, where that area that used to be above water is now all underwater. Okay, so it was one of the biggest floods in 140 years. It's very wet winter, spring, and caused this flooding downstream. Now here's an example of what we call flash flooding. This actually occurred back in 2015, where we had 18 dams actually were breached and collapsed in South Carolina, and some even in North Carolina. But had these massive flash floods that actually wiped out some of these rivers. These bridges and dams that actually destroyed the area. It was actually, if you want to watch a video about this, it's back in 2015. Same thing happened during Hurricane Matthew. We had flash floods in that area. Okay, so I'm going to actually stop there because that's where we're going to stop for floods, and we're going to start into groundwater in the next